In the event that these indications of something going on under the surface are affirmed, they could change our comprehension of the universe and our place in it. The quest for life beyond Earth has reached wonderful degrees of complexity with the approach of cutting-edge space telescopes and observational advances. As space experts continue to push the boundaries of what's possible, they are not just examining the physical properties of far-off exoplanets, but also digging into their capability to harbor life. The technological advancements that have emerged over the course of recent decades are essential to this mission. One exceptional improvement is the progression in spectroscopy, a technique that analyzes the light emitted or absorbed by objects in space. By studying the spectra of light from distant exoplanets, researchers can determine the chemical composition of their atmospheres. This method has already provided critical insights into the atmospheric conditions of several exoplanets, revealing the presence of gases like hydrogen, helium, and carbon dioxide. These discoveries help in assessing whether an exoplanet could have conditions suitable for life. Another exciting frontier is the examination of exoplanetary atmospheric conditions. Understanding these patterns can provide clues about the conditions of distant worlds and their potential habitability. For instance, the discovery of seasonal variations in atmospheric conditions could indicate the presence of liquid water, an essential element for life as we know it. Scientists are also investigating the potential for extreme weather phenomena like severe storms or temperature fluctuations, which could affect the habitability of an exoplanet. The search for biosignatures, or signs of life, is an area of intense focus. Beyond the traditional search for oxygen and methane, researchers are exploring other potential biosignatures, such as complex organic molecules and rare atmospheric phenomena. The James Webb Space Telescope, with its advanced spectroscopic capabilities, is well suited to this task, offering the possibility to detect these subtle yet significant signs of life beneath the surface. In addition to direct observation, theoretical models play a crucial role in guiding the search for extraterrestrial life. These models help scientists predict what types of signals or conditions may be present on exoplanets based on known principles of physics and chemistry. They also aid in designing experiments and missions that could test these predictions. For example, models of exoplanet atmospheres can simulate the expected effects of various gases and environmental conditions, guiding future observational techniques. Furthermore, the incorporation of artificial intelligence, AI, into space exploration is revolutionizing data analysis. AI algorithms are increasingly being used to sift through the vast amounts of data collected by space telescopes and other instruments. These algorithms can identify patterns and phenomena that might be missed by human observers, providing new insights into the nature of distant worlds. Global collaboration is also playing a significant role in the advancement of space exploration. Researchers and scientists from around the globe are working together to share data, resources, and expertise. This collaborative approach enhances the overall understanding of exoplanets and accelerates the pace of discovery. As we look ahead, the continuous improvement of space technology and scientific methods promises to bring us significantly closer to answering one of humanity's most profound questions. Are we alone in the universe? The ongoing efforts and progress in this field highlight the remarkable advancements we are making in our quest to explore the universe and understand our place within it. Disclosures. As we keep on investigating space, we move closer to understanding more about the huge universe and our place in it. However long people have existed, we've contemplated whether we're alone in the universe. This inquiry still drives numerous scientists today. At this moment, the James Webb Space Telescope is breaking down different planets and moons, searching for signs that life could exist beyond Earth. The likelihood that life could exist elsewhere in the universe is gaining momentum, and this developing conviction energizes many about the chance of tracking down extraterrestrial life. In 1984, two American cosmologists, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI. They made a philanthropic association to listen for radio transmissions from space, hoping to track down something from intelligent life. They use radio waves because these transmissions can travel huge distances without losing strength. The Allen Telescope Array in California, which includes 42 radio telescopes, is at the center of their work. Despite SETI having listened for over 30 years, They haven't yet tracked down any obvious signs of extraterrestrial life. However, Jill Tarter remains hopeful. With today's advanced technology, she believes a significant discovery could be just around the corner. She longs for a global effort to see whether we are alone in the universe. Recently, excitement grew when NASA revealed that the James Webb Space Telescope might have spotted something resembling artificial light from a city on a nearby planet. The James Webb Space Telescope, positioned 1 million miles from Earth, is critical for space exploration. It sends back detailed data about the oldest parts of the universe and is specifically designed to capture details we've never seen before. This helps us learn more about how galaxies, stars, and planets form. Astronomers are using the James Webb's advanced tools, like its precision camera and unique filters, to focus on the light from stars and planets. By zeroing in on specific types of light, the telescope helps researchers determine the physical and chemical composition of distant worlds. However, this isn't the most impressive part. The James Webb Space Telescope goes beyond merely observing. It actively studies the atmospheres of various planets, searching for even the smallest signs of something beneath the surface. With its unparalleled ability to explore the universe, the Webb Telescope is leading us into a new era of discovery. Researchers have recently made some groundbreaking revelations in the universe. They found significantly more material hidden in massive galaxies than they ever expected. These discoveries are pushing experts to rethink their ideas about how the universe began and evolved. Each new discovery from the James Webb Space Telescope brings us closer to understanding the farthest reaches of space and what life might exist beyond our planet. With the help of the James Webb Space Telescope, scientists are probing deeper into space than ever before, gathering data on distant worlds that could be useful in answering fundamental questions about these exoplanets. Just a few years ago, our understanding of planets outside our solar system was minimal. But since then, astronomers have identified over 4,000 exoplanets orbiting other stars. This demonstrates how strong the interest in space exploration and technology has become. NASA believes these discoveries are just the beginning, suggesting that there could be trillions more exoplanets waiting to be discovered. As scientists continue their space investigations, they are eager to find where extraterrestrial life might exist. Sometimes they come across signs that suggest they're on the right track. For example, the Galileo spacecraft made an accidental discovery near Jupiter that indicated possible vegetation. This was a significant moment, marking the first discovery of what is known as a biosignature, specifically the vegetation red edge. This method detects life by focusing on how light reflects off it. Now, the James Webb Space Telescope is set to delve deeper into the search for extraterrestrial life, focusing on planets that orbit within the habitable zones around their stars. In the profundities of the room, the James Webb Space Telescope has seen something totally staggering. Awesome lights, incredibly reminiscent of Earth's clamoring metropolitan regions, emanating from Proxima Centauri b, an exoplanet 7 trillion miles away. Are you prepared to confront what lies beyond the stars? Could we dare to pause and ponder what could be conceivable in finding an advancement not our own? What secrets could they hold? And what does this mean for humanity's future as the world grapples with the consequences of this disturbing find? The James Webb Telescope's latest discernments suggest that beyond simple, inconsistent light, these might be conscious signals from an advanced civilization on Proxima Centauri b. Each shine and movement rapidly spanning this immense distance invite speculation that we might be on the edge of the most spectacular discovery in humanity's history: contact with a different universe. This part of space, once thought calm and desolate, now whispers of possible existence. With each snippet of data, we inch closer to potentially altering history. As the telescope researched the vastness of space, it found something enchanting on Proxima Centauri b. The faraway exoplanet sent lights that resemble those from metropolitan cities on Earth, indicating the possible presence of an alien civilization. This idea has generated massive excitement and interest among scientists. It may indeed be the revelation they've been waiting for, highlighting the presence of intelligent life forms who might be designing their networks in ways we've never imagined. David Kipping, an astronomer at Columbia University, described the planet where these lights were observed as particularly complex. This complexity arises because, Unlike most rocky planets that absorb light and emit infrared energy, this exoplanet behaves uniquely due to its exceptional relationship with its star, Proxima Centauri. Yet, this isn't the only remarkable aspect. The discovery by the James Webb Space Telescope showcases just how powerful this apparatus is. Its ability to detect infrared light was key in observing these astonishing lights, showing us how much more there is to discover. The power signals from Proxima Centauri b are essential for understanding what its environment might be like. Scientists must continue using this telescope to explore the planet's atmosphere and investigate whether it could truly support life. The James Webb Telescope excels at perceiving infrared light, which helps it observe Proxima Centauri b's nighttime activities. Many space telescopes struggle to observe faint lights in the vast darkness of space, but the James Webb Telescope can capture even the smallest glints. This makes it ideal for checking if the assumed city lights on Proxima b's dark side are genuinely artificial. The telescope can identify any artificial lights in space if they emit within a specific narrow frequency, much sharper than ordinary starlight. Proxima Centauri b has a close relationship with its star. The side facing the star would gather energy from intense sunlight, while its dark side would also reflect some light. As Proxima Centauri b orbits its star, it experiences a constant cycle, like Earth, with hot days and cooler nights. The planet shows significant temperature differences, largely due to its configuration. For example, if Proxima Centauri b doesn't have an atmosphere, the temperature difference between day and night would be extreme. With gases or oceans to moderate these extremes, the day side would become intensely hot, while the night side would freeze. These sharp temperature contrasts intrigue astronomers because they can reveal insights regarding Proxima Centauri b's atmosphere. With its strong infrared imaging capabilities, the James Webb Space Telescope can measure the planet's heat, providing crucial information about its environment. However, the most exciting part is that the James Webb Telescope's orbit around Earth is aligned with Proxima Centauri b's orbit, allowing it to observe the planet's constant cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step is to focus on its chemistry to see if it could support life. Signs like oxygen, water vapor, and methane could indicate that the planet has conditions suitable for life. Observing these components on Proxima Centauri b would strengthen the case for its ability to support life, prompting detailed assessments and analyses of the light passing through its atmosphere. But here's the catch. The James Webb Space Telescope can only observe a few of the nearest planets that might be habitable. For a broader perspective on more distant planets, scientists eagerly anticipate the extremely large telescope YELT, which will begin operations in 2028. The YELT is expected to provide a clearer image of what distant planets' atmospheres are like and how likely they are to support life. Researchers are excited about the new insights that the YELT and other future telescopes will bring. In the meantime, the James Webb Space Telescope remains a crucial tool for studying planets outside our solar system. Despite its limitations, it continues to provide valuable data that could transform our understanding of the universe, both now and in the future. As we move into the next segment, we will further interpret these thrilling discoveries, creeping closer to possibly groundbreaking revelations. Looking forward, new space telescopes will aim to reduce the brilliant light from stars, making it easier to observe the planets that orbit them. This is akin to shielding your eyes with your hand to see better in bright sunlight. By reducing the starlight, these advanced telescopes will be able to capture the faint glow from distant planets more effectively. This clear view will help scientists study the atmospheres of these planets and determine if they could support life. However, this is no simple task. Researchers must carefully distinguish gases produced by living organisms from those resulting from natural processes, like volcanic eruptions. They need to fully understand these distant planets so they can accurately identify signs of life and avoid being misled by natural events. The James Webb Space Telescope opens up extra opportunities for future discoveries.